For this constant acceleration question, the first bit's not too bad. The second part, part B, is where it starts to get a bit difficult. So we are told that a stone is projected vertically upwards from point O with a speed of 19.6 meters per second. We're modeling the stone as a particle. It's moving freely under gravity. Freely under gravity means that the only force acting upon it is weight. And if that's the case, then it experiences an acceleration of 9.8 downwards. Then we can use SUVAT. We're trying to work out the greatest height above O reached by the stone. So let's draw out a SUVAT table for this scenario. Right, so the initial velocity is 19.6. The height is what we're trying to work out, so we want to work out the displacement. Acceleration is minus 9.8, so I'm considering the upwards direction to be positive. The final velocity, when an object reaches maximum height, it stops for a split second before it comes back down again. So at that point, the velocity is 0. So that's what our final velocity would be. And then with these four quantities, we can then work out S by using v squared is equal to u squared plus 2as. Rearranging for S, v squared minus u squared over 2a. Plugging what we have in, 0 minus 19.6 squared, all over 2 times minus 9.8. And this will be 19.6 meters when you type it in. That's part A. For part B, find the length of time for which the stone is more than 14.7 meters above O. Alright, so let's draw a diagram to represent the scenario. So let's say our particle starts here, it goes upwards, and then it comes back down. So let's say that this height here represents a distance of 14.7 meters above ground. So then we're trying to work out the time for when the stone is more than 14.7 meters above O. That's this bit here, that top region. We can do this by setting up a SUVAT table with our initial velocity being the velocity when it leaves the ground, 19.6. Our displacement would be 14.7, which is the height of the stone. The acceleration is still minus 9.8. So if we use these quantities and work out what t is, then what we work out is the times when the particle is at 14.7 meters. There are 2 times. There's this time, and there is this time. For both of those times, when I say both of those times, I mean the time it takes to go from the ground to this point, or from the ground to that point. Both of those times have the exact same SUVAT quantities. The displacement is 14.7 for both, the initial speed is 19.6 from the ground, and the acceleration is minus 9.8. So when we set up this equation, we should get 2 solutions for time. And that is consistent because when we put this into this equation, which gives us, which contains all of the quantities that we are considering, S, U, A, and T, that will give us a quadratic. So 14.7 is equal to 19.6t. A half A would just be minus 4.9. And then rearrange this. So this quadratic has 2 solutions, and they will be times t1 and t2 when the displacement is 14.7 above the ground. Put this in our calculator, we get 2 times 1 second and 3 seconds. So in other words, it takes 1 second to go from the ground to here. It takes 3 seconds to go from the ground to there. So therefore, we find the difference, t2 rather, minus t1, and we get our time, that it is above 14.7 meters. 2 seconds, which is our final answer.